Please welcome Martin Rantzer, Linköping University.
Hello, my name is Martin Rantzer, and I'm the head of the Department of Science and Technology at the Linköping University in Sweden. We have nominated NINC because we firmly believe they will revolutionize the organic and printed electronics market with their highly conductive, eco-friendly, and stable inks. NINC are making stable electron conductive polymers, so-called N-type polymers. These polymers can conduct electricity just like rigid copper or silicon, but can be printed at room temperature on a large scale and are very cost efficient. These inks hold the long-awaited key to unravel the full potential of organic solar cells, batteries, and wearable electronics. So very soon you will have a product in your hand, in your shirt, or on your roof that will be in part powered by NINC. Thank you.
Breaking the wall of inefficient organic electronics. Johannes Bintiger, NINC.
Hello. Electronics are the foundation of today's digital age. And it all started in 1947 with the invention of the germanium-based transistor. Replacing germanium with silicon enabled much more powerful metal oxide semiconductor designs. But the real breakthrough came in the 60s with the invention of the complementary MOS design, which makes use of positive p-type and negative n-type properties. Every single electronic device you're using is based on this technology. In 2000, the Nobel Prize in Chemistry was awarded for the discovery of conductive polymers, which enables organic electronics. Instead of rigid metals, this technology is based on printable organic semiconductors. And this can be used for making complementary circuits and foils. Amongst other things, this can be used to make printable and flexible solar cells, which are key components to meet energy and climate targets. Our partner Ecofriendly and others are currently upscaling production of these solar cells to print the equivalent of one nuclear power plant per month. But there's still a lot of room for improvement because most of these materials are p-type, therefore not taking advantage of the full complementary designs. And this is exactly where NINC comes in. NINC enables the first N-type conductive polymers for complementary designs to boost solar cell, battery, and display performances. Over the last 80 years, we went from very large stationary electronics to portable electronics in our hands, and recently got a flexibility upgrade. Whereas conventional electronics are only using electrons, organic electronics can also use ions. And ions, very much simplified, are the language of biology and nature. And this is the key to actually enable human-centered electronics. Think about this. Today's best supercomputers can almost outperform the human brain in terms of raw computational power. But just by listening to me, each and every one of you is outperforming these power-hungry beasts in terms of energy efficiency, cost, and size by a lot. So NINC is actually taking inspiration from nature to make more energy-efficient polymers and applications. And here's how it works. In the case of a solar cell, light is converted into charges of opposite sign, and these are extracted via the electrodes to generate power. Please note that the negative sign here is moving much slower than the positive one because the N-type materials are not as good as the P-type materials. Now, if you apply NINC, the N-type side gets enhanced, which leads to an increase in power efficiency and overall device performance. Since a solar cell is just a display in reverse, you can also use NINC for displays as well. Over the last decades, the creation of a high-performing and stable conductive polymer was always pursued, but never achieved. Due to energetics, the p-type behavior is actually favored, and n-type behavior is rendered unstable. We not only solved the performance issue by clever chemical engineering, but also the stability issue. And our entire patented process is based on green chemistry, which is scalable, because we are only using abundant starting materials in a single reaction step, and no toxic or expensive catalysts are used or solvents are used. So our team consists of chemists, physicists, and business experts, and we will enable a new era in organic electronics, which already has a market size of about 140 billion euros currently, with applications ranging from displays to solar cells and biosensors. Due to the lack of N-type materials, the market is dominated by P-type materials such as P.PSS. Therefore, our business plan is based on direct sales to solar cell, display, and capacitor manufacturers. And we are en route to become the market leader for N-type conductive inks. We are expanding our unique IP and are entering strategic partnerships with key players from the field. Long term, we will focus on human-centered electronics using our upcoming water-based inks. N-ink is really the game changer the industry has been waiting for decades, and the hammer to break the wall of inefficient organic electronics. Thank you.
Thank you. Questions, anyone here? First row, please, to start with.
I heard you talk about solar cells that you print and displays, if I got you right. But,
Yes.
but this is not limited to those applications, is it?
No,
I mean,
no.
It could be any electronical whatever.
Exactly. Everything where you need a charge extraction layer, for example, is a potential application for us. I just highlighted those because those are the most apparent applications. Yeah. But solar cells need that in order to actually improve the device lifetime and the performance. But even more subtle, you also, if you use inorganic components, which are used currently like zinc oxide or tin oxides, the nanoparticles these inks are not compatible with the subsequent layers or the layers beneath them. So you actually improve their overall film forming properties and make a better device.
Okay, we have 1, 2, and 3 questions, and then
Wait.
we will see. Yes.
When do you think your first product is going to be on the market?
It's already on the market.
Okay.
So
Which
we.
one like the solar panels?
Oh, so I forgot. We launched our first product in April of 2021, and we are in the customer validation phase. So we are talking to various industries like solar cells, like displays, but also polymer capacitor manufacturers in order to evaluate the performance. Because it's not just that you need the performance, it also needs to be compatible with existing processes.
Mm-hmm. Next question, please, here.
Yeah, for the solar cell application, could you give us some concrete examples of KPIs and how much they are improved by your technology?
Yeah, so as I said, with our partner Epicent, we are currently exploring this. We hope to achieve an improvement of up to 2%. Actually, the most important parameter right now is the process integration and the compatibility with the subsequent with the layers beneath. And this is where actually the solvent that we're using comes in quite handy.
2% efficiency or what?
2% efficiency increase.
Okay.
Okay. Is this, otherwise we have one here.
Can you go to 3D with your...
I'm sorry, but
sorry.
the online was before, and then we have one here, and then it's you. I'm sorry, I'm strict on the order.
Anna Helen has actually asked the same question about efficiency, but maybe to follow up on this, is 2% a lot on this in the solar market? Because it doesn't sound a lot to us.
It's a lot. So the example I gave in the presentation is based on the fact that these roll-to-roll printing processes can print rolls of 60 meters per minute with a size or a width of 2.5 meters roughly. So that means you can print per month in one pilot line about 6 square kilometers. Now, if you take into account the solar radiation, 1,500 watts per square meter, and multiply that by that amount, 2% is huge. Mm-hmm. But we are in the validation phase, so I can't, it's not published yet.
Okay, next question very fast, please.
What is the business model behind it? Do you license the technology or do you produce it yourself?
Both. So right now we are making direct sales, but we are entering these strategic partnerships, as I said, with solar cell companies, with display manufacturers and polymer capacitor manufacturers in order to evaluate how well it is suited for them. when it comes to real big upscaling, we are doing that right now, but we definitely need strategic partners. So we have actually entered discussions with one of the largest chemical distributors, and our inks should be on the market by this company by middle of next year.
Okay, I'm very sorry not to be able to take your question. I try to be as just as I can in the order and to give a chance to everybody. Thank you very much.